Hello, and thank you for joining us for the Consulting Specifying Engineer webcast, Holistic Lighting Systems, sponsored by Lutron. I'm your moderator, Amara Razgas, with Consulting Specifying Engineer and CFE Media and Technology, and I'll be with you for this hour-long education session. Let's learn about this platform. If you're having trouble with your slides or with the sound, please refresh your internet browser or click on the Refresh Media button directly under the presenter's photo. You can control the volume settings by adjusting the volume on your own device. If you're having technical problems, please click on the question mark at the top right corner of your screen to do some system checks before contacting an online technician. If you do need an online technician, please type a message in the Ask a Question box and we'll respond in the Answered Questions box. To download the presentation slides, please use the event resources on the left side of your screen. Type questions for the presenters on the left side of your screen in the Ask a Question box. You may ask questions at any time during this presentation. The interactive Q&A will start in about 45 minutes. If you're interested in receiving one AIA CES approved learning unit for this event, you'll need to pass a 10-question exam. To take the learning unit exam and to download your AIA CES certificate, use the Learning Unit Exam tab option at the top of your screen. The quiz will open in a new browser window, so I recommend that you open a new tab right now because the link will break when this webcast signs off. In keeping with the American Institute of Architects Continuing Education System Policy, please take a moment to read the quality assurance slide. Thank you. And here are the learning objectives for today's event. We'll learn about these in the presentation, and please note that any red underlined text you see is a hyperlink in the PDF where you can get more information. Let's now hear from today's sponsor. At the conclusion of the commercial, you may experience a few seconds of silence to make up for different internet speeds. Please stay tuned after the video for today's presentation.
Every year, thousands of buildings are built or retrofitted. Every one of these spaces can benefit from smart lighting control that saves energy, improves comfort, and enhances productivity. Vive from Lutron is a simple, flexible, and scalable smart lighting control solution comprised of a full family of wireless devices that can be tied together to enable centralized control, monitoring, and system integration. Vive can help buildings meet stringent energy codes and improve building performance on budget and on schedule. And with a wide range of online supporting tools, meeting energy codes has never been simpler with Vive. Determine the energy codes in your project's location, design confidently with code-based application guides, and create your documentation quickly with room-based design files. Vive, the simple, flexible, scalable lighting control solution. The world leader in smart building lighting control solutions.
We've lined up two really great presenters today. Tyler Guylock is a lighting designer with Pivotal Lighting Design. He received his Bachelor of Arts in Lighting Design from the University of Manchester and interned with a niche architectural lighting design studio. His experience and expertise in well-rounded lighting design in corporate planning, public facilities, and high-end residential design allow him to master varied applications of lighting techniques to enhance architectural space. Michael Chow is a principal at Metro CD Engineering. He received a BSEE from Ohio Northern University and now serves on the ONU College of Engineering Advisory Board. He is the owner and founder of Metro CD Engineering and is a licensed professional engineer in several states. Michael is a Consulting Specifying Engineer 40 Under 40 award winner, and he's a member of the Consulting Specifying Engineer Editorial Advisory Board. All right, well, I'm excited to get started on this discussion. Tyler, you're up first. Let's begin.
Hello, everybody, and thank you for joining today's webinar. I know you're all very excited to learn about what a holistic lighting system is, so we'll just go ahead and jump right in. So in simple terms, a holistic lighting system is an overall building lighting and control strategy that considers user needs, space needs, energy efficiency, and control to provide comfort and quality of light. As you saw before, below are the objectives on what Michael, Chow, and myself will be discussing throughout this webinar, and we will, without further ado, continue.
Thanks, Tyler. I'll talk about codes, guidelines, and standards as they apply to lighting systems. So one of the first things you want to do when you do a lighting design is you need to know the applicable codes, guidelines, and standards. So on the screen here, there is quite a list of these different publications, and there is a hyperlink for each one of those. So you'll be able to click on them in the PDF and be able to see those documents. We're going to touch on just a few of these that are the most commonly used ones. ASHRAE Standard 90.1. And we also have the Energy Star we'll be talking about. And let's see here, move on to the next slide. The International Energy Conservation Code, the Illuminating Engineering Society, which is the IES, and the National Electrical Code, the U.S. Green Building Council, which administers the LEED certification, Well Building Standard, and federal, state, and local requirements. So with federal, it could be the military. I know the different branches of the military may have different requirements, and other agencies such as the GSA have their own publications and their own guidelines, and state and local requirements as well too. So you want to make sure you take a look at all these different codes and standards to make sure that it applies to your project. I had a project where it was for a jeweler, and he wanted all halogen lighting. And if we would have went all the way through design with the halogen lighting, it would not have passed the energy code. So this is something you definitely want to take a look at and research first. So next we'll talk about energy codes, which codes apply. And a good starting point would be to check with the local government website or call the building department and find out the requirements. Specifically what energy code, if it's ASHRAE or if it's IECC or something else. The U.S. Department of Energy has a website that provides an overview of what's required for each state. And that website is energycodes.gov. And when you go there, you just type in the name of your state and it'll bring up all the applicable codes. And it's important to know the year that it's been adopted for a code for your state. So I'm here in Ohio, and even though it's 2021, we're using ASHRAE 90.1 2010. So I think some of the mistakes lighting designers make is they assume it's going to be the latest version. So that's something you definitely want to confirm. And some cities and counties adopt their own energy codes that are more stringent than the state level. Fortunately, here in Ohio, the building code is standard for an entire state. So there aren't any local building codes or lighting guidelines or codes that we have to abide by. Okay, next we'll talk about ASHRAE Standard 90.1. And this is updated every 3 years, and the latest one is 2019. And again, you have to check for your particular state or locality which version they're using. So in Ohio, we're using 2010. So similar to the IECC, which we'll cover later, it covers many aspects of energy efficiency, and they're listed here, but most importantly, at least I think so, is the lighting. And lighting also requires commissioning, starting with ASHRAE 90.1 2010. Some jurisdictions adopt this code and also publish their own supplements or amendments. So here in Ohio, there actually is an amendment that with the ASHRAE 90.1 2010, there is a requirement that 50% of the receptacle loads have to be controlled by occupancy sensor or time of day clock. Well, Ohio has decided to disregard that particular requirement, so it's not part of the Ohio code as far as 90.1 is concerned. Okay, next we'll talk about the Title 24, and this only applies to California, and it's updated every 3 years, and 2019 was the latest version. So there's some unique control requirements with Title 24. Corridor lighting has to be reduced 50% when it's unoccupied. And then you also have to have demand response capability. So what this means is the utility company, power company, they can send a signal to reduce the amount of energy consumption. And this could apply to lighting too. So you could dim the lighting, you could turn off some of the lighting in some areas. And this code is available online, and we have a link to it. I just lost my video and audio. So, okay, I got it back. Sorry about that, guys. So next is the International Energy Conservation Code, and this is abbreviated IECC. And it's published by the International Code Council, and it goes along with a whole suite of other codes that they have. The jurisdictions normally adopt all these codes together instead of individually. And like the other codes that we talked about, this is updated every 3 years, most recently in 2021. And it covers essentially the same type of items that the ASHRAE Standard 90.1 does. And it also states that ASHRAE 90.1 is an acceptable alternate compliance path. So when you take a look and let's say you want to use ASHRAE 90.1, you go with the one that was adopted 2 years prior to the IECC. So for example, in Ohio, the IECC version is 2012, so we use the ASHRAE 90.1 2010. Next is the National Electrical Code, and this is updated every 3 years, and the latest is 2020. Again, you want to check with your local jurisdiction and find out what year they're using, what version they're using, and it's codified by the local jurisdiction usually. And different than energy codes, the NEC focuses on safety and not necessarily energy savings. So what would be an example? So with LEDs becoming more popular, the NEC has addressed the use of LEDs and also CAN lighting fixtures. So there's a requirement that if a CAN lighting fixture, if it actually touches thermal insulation, then it needs to be IC rated. And it will say that right on the fixture, and IC just means insulation contact. If it doesn't have that rating, then it needs to be at least 3 inches away from any thermal insulation. Okay, next we'll talk about the Ies Handbook. And this is a great resource to help lighting designers with the design and also different applications. It actually even goes into how the human eye works and how the perception of light works within humans. It does talk about the design and talks about some strategies and applications. This would be your different type of occupant spaces, different type of buildings, and then they have what are called recommended practices that go into a little bit more detail. So here are the various.
Really quick, Michael, I just want to make sure people know that the Ies Handbook is not code required lighting levels. There are codes that will institute it as requirements, but it is not necessarily required by code.
That's a great point, Tyler. Thanks. So it's recommendations. And what I've seen is, for example, some universities have said you must follow the Ies Handbook. So they will make it a requirement, but the Ies by itself is a recommendation. So thank you, Tyler. Thanks for pointing that out. So here are the different topics that are covered by the Ies Handbook. We won't have time to go through every one of these, but as you can see, it covers everything from color, which is where a particular light source is either warm or cool, and it talks about luminaires. And again, a luminaire is a complete lighting fixture, and that includes the lamps, It includes the housing, includes the lenses. So when you hear somebody say luminaire, they're talking about the entire lighting fixture. Like I said, we won't have time to go through every one of these, but these are the main topics that are covered. And here are the different applications that are covered by the IES. They actually break down each one of these with recommended foot candle levels, horizontal and vertical. So here's an example of how you would do lighting design. This is for a interview room. And what they have listed here is this first, well, actually, this tells you the height of where the measurement should be taken. And these are the foot candle levels, or actually the lux, which is 400 lux is 40 foot candles. And this is the horizontal foot candles. And these are vertical foot candles. So you really need both. And the reason why there are three different numbers here, it's depending upon the age group. The first is for occupants under the age of 25. And the next one, which is the one in gray, is ages 25 to 65. And then the last one is over 65. So most office buildings we designed for the middle one, which is between 25 and 65. So this basically tells you, again, it's a recommendation that a formal interview room, you have 40-foot candles measured at 2 feet 6 inches above finished floor. And that would be your typical desk height. And then 15-foot candles, those would be the vertical foot candles, and that's 4 feet above the finished floor. So there are recommended practices that go into a little bit more detail as far as they've got different ones for industrial facilities, they've got ones for healthcare, hospitality. So those provide more detail than just the handbook itself. So next, I'll turn it over to Tyler to talk about designing a lighting system for the occupant.
All right, so designing a lighting system for the occupant. So when you're starting your design process, there are many things that you want to take into account. And I just want to remind everybody, this is a very high level view at this process and kind of, things to think about, especially as architects when you're designing your spaces. So this project was a storefront shelled space within a larger healthcare facility. It was 530 square feet. The RCP was originally provided by the architect. And it was designed by our company in 2015, 2016. The lighting that was originally provided by the architect and the RCP, as you can see here, were can lights, and they were spaced roughly 10 feet on center in one direction and 6 feet on center in the other direction. All right. So as we started designing this facility, one of the things that we started to ask ourselves is, what was it going to be used for? And this one was really interesting because it was becoming a telemedicine space, which obviously last year became very important and interesting in terms of finding out how well it kind of stood up and worked last year with all the challenges we faced with COVID. So as you can see here, the workstations are along the wall. This space questions that we had were, how long was the space going to be occupied? As you saw in the last picture, there was a wall of glazing that was to the exterior lighting, and all that stuff to consider as we move forward. So in thinking about the design, it became very obvious that downlights probably were not the best option in this facility, given the fact that the workstations are facing the wall. So the can lights would either be above the person or behind the person, which would cast shadows for the doctors that are on these telehealth visits. Which would make it hard for people who were calling in to get health advice to see their face. Not only is that a problem just in general, but if you think about people that might be calling into these, they might be visually impaired or hearing impaired. So it might be very important that the people working in these spaces have light on their faces. So we'll continue moving forward. So this is just a 3D render of kind of what the space looks like. So as you can see here, the monitors are double height. Each person has six monitors in front of them. And then there's a wall behind. The ceiling was higher above where they're working, and that sort of thing. So then the question became, with that wall glazing, what was the time frame this space was going to be used for? So this space, given that it's telehealth, it could be used 24/7. So we have to consider nighttime versus daytime, and the light levels that need to be in there. Then there's also the fact that they're on camera, so we have to make sure there's lights on the face, lights on the task plane where people can write notes, the doctors can write notes as they're on these health visits, and that sort of thing. And then given the fact that it's a 24/7 facility, you have to think about controls, because the general principle for lighting with daylight is that you want brighter days and darker nights. So you might want a little bit brighter during the morning, so you'll have the lights up higher, and a little bit dimmer at night as the lights, or as the sun goes down, to kind of give that visual cue for the people working in these spaces for long periods of time. Excuse me. Moving on. And then the next question is, people are working in these spaces for 12 hours at a time. Doctors work long shifts, more often than not. So then it became comfort for the people working in these spaces. So the original design was to have dark walls behind these monitors. Well, it doesn't matter how much vertical light I put on those walls, you're going to be struggling with getting light onto the faces because dark walls absorb light. So then the people working in these, so they're not going to have light on their faces for the people on the camera. And then the other problem is the aspect ratio of brightness from the monitors versus darkness on the wall behind. So the people working in these spaces are going to have severe eye fatigue by the time their shift is over. And the IAS does have recommendations on what that contrast ratio should be, but in general, dark walls behind bright monitors are going to throw that out of balance, and the eye fatigue is going to set in. So then it became, what were our options in terms of lighting? It was very clear to us that downlights probably were not the best option already, because they're going to be above the people's heads. They don't have good side-to-side throw. So you're going to get scallops on the walls, creating a cave-like effect. So it's not going to be very comfortable for the people working in there. But also, those downlights are very direct luminaires. So they're going to create shadows on the people's faces, especially under the eyes, under the nose, which are really key components to being able to read lips or understand if the quality of the audio is not very good, or if you're visually or hearing impaired, that sort of thing. So that became very clear that downlights were probably not the best option going forward. So then we considered doing something more like a 2x2 lay-in troffer. So these troffers are good because you can get direct indirect troffers that give you a little bit more softer lighting and indirect lighting that bounces around, so it can kind of fill in some of the shadows, but it also has good side-to-side distribution, so you get some reflection off of those vertical surfaces behind the screens. But it became very apparent that this probably wasn't the best option, because it is still more direct, so you're still getting shadows on the face, and it's not providing a ton of light off of those walls, because it's mostly the indirect portions that are hitting those walls. And you're getting shadows from the monitors that are in front of the people, so you're going to be underlit. You're not going to have the right amount of light on your face. So moving forward from that, we considered doing a wall mount, direct indirect. This idea we liked at first because it lit that back wall. So it really corrected that contrast ratio between the bright screens and that dark wall behind the monitors. And then it provided a nice uplight onto that ceiling, and indirect fills in shadows. So it really helps with that. The problem we ran into, again, is you had those monitors there. So you still got some shadowing from the monitors onto the desk in front. And then on the uplight, or sorry, my apologies. And then with the fact that you're lighting that wall and the uplight portion of that wall, you're getting some backlit qualities for the people across the room in their video cameras. So that didn't quite work for us, because then they might not be seen as well from the cameras, which we couldn't have. So we moved forward, and what we ultimately settled on was a direct-indirect pendant light. And it was really key on the placement. We wanted to get it close enough to the wall to get some direct, or to get some bounce off and really correct that that ratio between the bright monitors and the walls. It gave us a nice, even direct or indirect ceiling glow, which filled in shadows. We still have, depending on the placement, you can still have some backlit problems going on, or some underlit problems going on, but we were able to really solve that with thinking about the placement. And then the other thing to think about now is they're in these rooms for 12 hours. They're not going to work for 12 hours straight. So there's a little respite area off to the side, the copy space. And so, controls became a big aspect, and trying to make sure we were zoning them appropriately. This particular case, the owners wanted tunable white in here, which became a whole thing in and of itself, because as we know now, tunable white does not equal circadian lighting. And for those that don't know, circadian lighting is really trying to mimic daylight outside. So this was a very small space. We have windows, which are going to provide plenty of daylight during the day, and it's going to go away at night. So we already really had the circadian lighting. But the other problem with the tunable white in the spaces is we're controlling it in these small areas. And we have the direct indirect pendants, the respite area. We were going with more of like a hospitality field to give them a nice relaxation space. You're never going to get that tunable white, that white color. So whether it's 3000, 3500, 4000 to match evenly. And then dimming was also a problem. So we did end up with static white. But those were all things that we considered to try and think about the whole picture, make sure they were comfortable, the space was lit to what was necessary, and that sort of thing. So that was designing the space. It was an interesting challenge because it's such a small space, but it did take a lot of thought and putting it into a workable solution for these specific owners. All right, so now we're moving on to occupant priority lighting strategies. So one of the major strategies that are out there for occupant priority in terms of making sure you're thinking about the occupant and their health and well-being is the well-building standard, which focuses on creating a health and well-being, or focuses on the health and well-being of occupants in the space. That's its main objective. There are two general rules of thumb that they like to claim as their most important core values, and that's brighter days, darker nights, as I said earlier. That's trying to mimic what it's like outside, not necessarily with spectrum, but just in general, if you're outside during the day, it's brighter. If you're outside during the night, it's darker, and really giving you that visual cue. So the Well-Building Standard version 2 has 2 lighting requirements that you must follow to meet the Well-Building Standard. The LO1 is daylight exposure, access to daylight, windows, being the proximity of windows, getting that daylight into the space. And then L02 is the visual lighting design. So essentially, this is you're following some sort of standard or requirement, whether it's the Ies Handbook or the subsequent RPs, and following that to as your goal for your design in the space. So continuing, then on top of those 2 requirements, they offer 7 other optimizations, as they're called, that you can add on top of that to really give you a better accreditation from well-building. So L03 is circadian lighting, so that's mimicking daylight with electric lighting. L04 is electric light glare control, which is fixture base. So there's fixture base, which is using the UBGR, and room base, which is using a computer model to prove that you are having that glare control. L05 is enhanced daylight design so this is whether you're controlling the amount of light coming through the glazing, adding light shelves or stuff like that to the building. You're implementing techniques like that to really control the daylight that is coming into the space. L06 is also enhanced daylight design, but this is proving it with calculation. So L05, you just have to have those elements. L06 is taking it a step further and proving that those elements are doing what they're saying they're doing. Excuse me. L07 is visual balance. So that's meeting specified ratios and having the designer submit a narrative so you either have to meet specified ratios as spelled out by a recommendation or recommended practice, or you have to have a lighting designer submit a narrative of the design, essentially. L08 is the electric light quality. So that's the quality of the luminaire, of the light that the luminaire is producing. So a good CRI of 90 plus or higher, a CRI of 80 or higher with an R9 value of 50, and then controlling flicker and meeting those specific flicker requirements. And then L09 is occupant lighting control, and that's providing controllability for users via zoning and supplemental task lighting. And if you want more information on this, I recommend you click the link on this slide when you download it for the Well Building Standard and read it and really learn about it. There's plenty of videos online you can follow as well. All right, and now we are moving on to energy saving strategies, which Michael and I are going to tag team. So I'm going to click next, Michael. Okay, and you're going to talk about DLC, and I'll do the Energy Star.
Okay, great. Thanks, Tyler. So for DLC, that's the Design Lights Consortium, and Energy Star, that's probably the more popular one, but both of these cover high efficacy, which is the lumens per watt, and they both aim to save the environment, improve energy efficiency, and save money. So for the DLC, where we've seen that come into play, not necessarily from an energy code standpoint, where the energy code states you shall use DLC luminaires, but where we've seen that is where a particular agency, whether it's a university or if it's a branch of the government, they want to use DLC luminaires. And the reason to use DLC luminaires is the fact that they go through some vigorous testing. They actually pull luminaires off of the line and test them, make sure that they meet all the specifications as far as color and the color temperature, CRI, which is color rendering index, and the efficacy, the lumens per watt. And we also have had instances where there are utility company rebates that offer energy savings. There's a requirement that the luminaires are DLC compliant. And if they are DLC compliant, then the customer could be eligible for a rebate. Now, we had something kind of odd happen to us where we specified a basis of design DLC luminaire, and by the time it went out to bid and award to a contractor, DLC had revoked that particular luminaire certification. So it's important, I found out, to check the certification all the way through the process to make sure that something like that that doesn't happen. Tyler, do you want to talk about Energy Star next?
Sure, I can definitely talk about that. So I want to add one more thing on the DLC. So, and I know it says on the slide, but I'm going to say it anyways because it's never bad to remind you. DLC is great because they focus on commercial lighting applications, and they only do lighting. They don't certify refrigerators. They don't certify air handling units. They only focus on lighting. So that's a real key. And just going into Energy Star, that's a real key difference. So Energy Star is put on by the U.S. government, and it's managed by the EPA as well as the Department of Energy. They focus on a whole broad swath of different components of the energy world. So refrigerators, TVs, all that. You'll see that Energy Star label. I'm sure you've all seen it. but they also do lighting. And they focus not necessarily more on, but they really do focus on residential and hospitality type lighting installations. So downlights, a lot of those small linear tape lights that we like to use now with those remote drivers. The tapes aren't often Energy Star rated, but the drivers will be. And they don't really focus. Another key thing to really pay attention to is Energy Star and DLC really don't overlap. DLC does not list downlights. So if you have a project that says we have to have DLC, you're going to want to have that conversation with your architect or owner or whomever is requiring that to really ensure that they understand that if they have to be DLC listed, you're adding money to your project because linears are more expensive if that's your solution for not having downlights. Typically, DLC requirements for rebates, which Michael, did you touch on that?
Yes. So we've had to use DLC luminaires for most of our projects that have rebates.
Yeah. So your local energy company, whoever that is, will tell you if they offer rebates or discounts on your bill if you're using DLC. But typically, it's a percentage of the total connected lighting load has to be DLC listed. So that's the other thing to talk about with owners is even though the downlights may not be listed as DLC, if the rest of the building is, you've met that percentage. So just things to think about as you're going forward. All right, we will continue. And Michael is going to talk about LEED.
Okay, great. Thanks, Tyler. So LEED stands for Leadership in Energy and Environmental Design, and it's administered by the U.S. Green Building Council. It was introduced back in 1998, which was kind of news to me when I was doing research. I hadn't really done many LEED projects prior to 2000. And LEED version 4 is the latest version. There's a LEED version 4.1 that's in beta. I actually personally have worked on every version of LEED except for version 1. And it's the industry recognized standard for green building design. So what are some of the strategies that incorporates into LEED? It's not just energy efficiency, which is the performance-oriented strategies, but it also helps buildings consume fewer resources, reduce operating costs, increase value, and create safer and healthier environments for its occupants. So what all does that mean? It doesn't just focus on energy efficiency, it focuses on occupant comfort, and we'll get into that as far as lighting is concerned. And it's basically, it's good for economics because you save green, you save money, and it's good for the environment, and it's also good for the building occupants. So it's a win-win-win. There's 7 different categories for LEED, and lighting affects a couple of these that we'll go into more detail in the next slide. So these are the lighting-related prerequisites and credits for LEED, and this is pretty broad. It covers the latest version of LEED as well too. So the first is it's energy and atmosphere. It's the fundamental commissioning and verification. So I think I mentioned earlier in ASHRAE 90.1 2010, commissioning is now required for lighting. So that's something that lighting designers will want to make sure that the building owners or agencies that they're working with and the contractors know that that's a requirement now. And that could be done by either the lighting designer or a third party. So, but as far as LEED is concerned, for fundamental commissioning, it can be done by the same person that designed it. Once you get into the enhanced commissioning, LEED wants or requires that a third party do the commissioning, and there's additional credits that are available from that, and that includes training of the building operations and maintenance staff and reviewing the submittals. So for the enhanced commissioning, the lighting designer would be taking a look at the shop drawings, the submittals, approving them, making sure that if there's a requirement such as DLC, that's met. Next is the optimized energy performance prerequisite. And again, that's a prerequisite. So LEED requires that the buildings be designed that are actually better than the energy code. So if you meet the energy code, then your building won't be LEED certified again, because this is a requirement. So how does lighting come into play? Well, obviously lighting uses energy, and how do you go about achieving this credit is we typically, the lighting designer works with the mechanical engineer who normally does the energy model for the entire building. So the building gets modeled and includes lighting and the schedule that the occupants will have. For example, they could be 8 to 5 or 6 to 6 as far as their schedules are concerned. So all that information gets plugged into the computer model. And then at the end of the simulation, it can determine how much energy usage there is for an entire year. And then you compare that data against ASHRAE 90.1 or IECC, and you find out what the savings is. And based upon the amount of savings, you can not only just get the prerequisite, but you could also get additional credits awarded. So we did a net zero energy building, and in LEED version 4, we actually got every single credit for the optimized energy performance, which again is a prerequisite and a credit. So that was a nice feather in our cap. Advanced energy metering, again, that's in energy and atmosphere. So that is where you would actually put in a separate meter just for lighting. And that way you can track, as far as your lighting usage is concerned, you can track that against your energy model. And that allows you to get a good feel if there's something wrong. This helped us with the particular project where the energy usage was much higher than what the energy model was. And it turns out that the contractor had jumpered the lighting controller, which controls all the indoor and outdoor lighting. And they jumpered it so the lights were on all the time. He did that for testing purposes, and he never forgot to take the jumper out. So with the fundamental commissioning, that was actually commissioned and it was working properly. But after the commissioning was done, the contractor had gone back and they were troubleshooting, I think, an occupancy sensor, and they inadvertently left that jumper on. So that having that separate meter, it was good because it helped us realize that there was something that was wrong with the operations of the lighting. Next is the demand response, similar to Title 24. If you have a demand response where you reduce energy usage, then you can get a credit for that. And the last credit is for the indoor quality, and that's where you can get a credit for lighting. So LEED requires that 90% of individual occupant spaces that the occupants have control of the lighting in those spaces. It could be task lighting, it could be dimmer controls, it could be light switches. So again, LEED focuses more than just energy savings, but it also provides occupant control. And the thinking behind that is that the occupants can control their own lighting. Let's say there's plenty of daylight and they don't need to use all the artificial electric lighting. They have the ability to control that. So LEED is not necessarily known as an energy strategy, but it does incorporate that. So here are some other control strategies to use that can help you meet your energy code. So again, first off, make sure you know what your energy code for your project is and the requirements. They're automatic and manual controls. I think we've seen them all. There's occupancy sensors, and you can make them so they're automatic on, or some energy codes now require manual on, where you have to actually turn on the lighting fixtures in a room. You actually have to flip the switch to turn them on, and then the occupancy sensor can take it from there and keep the lights on. Daylight harvest sensors for skylights and sidelights that basically automatically dim the lighting based upon available sunlight or daylight. Bi-level space controls, this allows you to have more than just on or off, allows you to do some step dimming. Exterior lighting controls, those are your photo cells and your time of day clocks. And stairwell lighting controls. Stairwells require one foot candle at all times, but then if it's occupied, then it actually has to bring it up to 10-foot candles. So occupancy occupancy sensor could help accomplish that. Just a quick case study on a project that I worked on and designed. This is a new engineering building in Ohio. Ohio had ASHRAE 90.1 2010 and the 2017 NEC, and it got LEED version 3 certified. This project used all LED lighting fixtures, and the watts per square foot that were allowed by the Comm check that we used was 1.2 watts per square foot. We actually came in at 0.45 watts a square foot, and that's a pretty significant reduction compared to the energy code. And what our lead reviewer actually wanted to see the shop drawing submittals for the lighting fixtures because he didn't believe that we achieved such a low efficacy or watts per square foot. So I think we got all the credits in this particular project as well. Just some more information about the project. We used a 4100 Kelvin color temperature. There was LEED fundamental commissioning and daylight harvesting. There was a lot of daylighting, side lighting that was available. So we used the sensors to automatically control that lighting. You can see in this picture, most of the lighting fixtures are off. So that concludes our presentation. Next, I'll turn it over to Amara to talk about Q&A.
I just want to add one more thing to LEED. One credit that you didn't touch ice on, but is also available is the exterior light pollution credit. So one thing that's different with LEED versus well building is it does also have an exterior component to it. So just keep that in mind.
Yeah, that's a great point, Tyler. I think I left that off because that credit's really hard to achieve. I think we've only been able to achieve that on a couple of our projects. So it has to do with light trespass onto adjoining properties and not having lighting that's above 90 degrees. So you're not getting any of that light pollution. So thanks, Tyler.
Yep. All right. Now we can move on. And I think Amara is going to talk through submitting questions if you have any more and what's going to happen afterwards. So
exactly. Yeah. Thank you, Tyler. And thank you, Michael. That is a lot of information to take in. So let's take some questions. Please type your question into the Ask a Question box and type the presenter's name before your question so I know who should answer it. We'll get to as many questions as time allows. Questions that we do not get to today will be posted online with answers at www.csemag.com. To download the presentation slides, you can use the event resources on the left side of your screen. And as a reminder, you may earn one AIA CES approved learning unit for this event. You need to pass a 10-question exam. To take that learning unit exam and to download your AIA CES certificate, please use the Learning Unit Exam tab option at the top of your screen. The exam will open in a new browser window, so open that right now so that it's available when this course is finished. And have you heard of CFE EDU? Click on the link in the downloadable PDF to register for free courses on designing electrical systems in rooms, smart buildings, and critical power systems. Registration is required, and you can take courses at any time free of charge. All right, so Michael and Tyler will now answer questions about this topic. Please type their name before your question so I know who to direct it to. And Michael, the first question is going to you. Who on the design team should sign and be listed on the CommCheck lighting compliance form?
Oh, that's a great question. So the CommCheck is a form that stands for commercial check, and it's available on energycodes.gov. And there's an online version and a version that you can download. And once you pick the energy code, it basically populates a form where you fill it out, and then it then produces a compliance report. And then there's the name, there's a blank line for name of the person submitting the form and basically did the design. So I actually talked to the Department of Energy about this because there's been a lot of misconceptions. So the professional engineer that is sealing the drawings with the lighting and signing the drawings should be the one listed on the CommCheck. Sometimes lighting designers, and not necessarily the PE, signs that, but actually straight from the horse's mouth, the DOE says that it's the design professional that signs it.
All right, got it. Tyler, the next question is for you. Can you explain the different uniformity ratios and how they pertain to the design recommendations?
Sorry, 1 second here. So the different uniformity ratios, I'm not sure I 100% understand this question. However, I will say that there are different uniformity ratios for different space types and tasks being generated. There are ones for, it could be in the same space. In manufacturing, for instance, there's ones for large versus small tasks. So if you're doing manufacturing of cell phones and you're soldering little bits on, which I get might be machines these days, you're going to have a higher light level than if you're in a large warehouse moving boxes for a manufacturing facility. So yeah, I mean, I can definitely take that one offline too and answer in a little bit more depth, but that's the general principle.
Good, okay, thank you. Michael, this next question is for you. Can you please touch on light switching strategies to meet energy code?
Sure. So I think we went over some of the strategies during the presentation. Some of the ones I didn't cover are related to the what's called bi-level control. So the energy code, whether it's IECC or ASHRAE 90.1, they require that instead of just an on-off, they require one more level. And ASHRAE 90.1 requires between 30 and 70% of the lighting, and I believe IECC is 50%. So there's multiple ways to do that. Back in, I think, the days of fluorescent lighting, you could have step dimming, or you would actually have a ballast that could set the level to 50% or 30% or to 70% of the full light output. But the energy codes also give you the flexibility to use a dimmer that dims all the way down to 0 and then all the way up to 100% to achieve that same goal. And with LEDs, that's something that's relatively inexpensive compared to the old fluorescent days with fluorescent lighting. So that's one strategy. I think that there's a time of day that you could use to turn off external lighting. I think that's one of the things we talked about with Tyler earlier. And you could also use a photo sensor just to make sure that the lights turn off. And then actually, I think one of the requirements is one of the energy codes that after midnight, the lighting has to be either dimmed or turned off for exterior lighting. And I think we talked about vacancy sensors too. ASHRAE 90.1 2010, which is LEED version 3, is based upon that. It doesn't require vacancy sensors, but that's something that you can do to help save energy. And in LEED, that could get you some extra optimized energy performance credits.
Good, lots of good details there. Thank you. All right, next question, Tyler. This one's for you. Let's talk Kelvin, 3500K versus 4000K fixtures. Which one is better for an office space?
So this one is a really hard question to answer because ultimately it comes down to the end user and what they're comfortable with. So I recently had a project here in Madison that the whole building structure it was wood timber, and it had a ton of daylight and fenestrations in the building. So we actually went with 3000K to bring in the color temperature, or bring in the warmth of the wood. But because there was the daylight, which is typically around 6,000, a little bit higher maybe, Kelvin, it offset that balance. So really, there's a lot of factors that can go into answering this question. For me personally, I prefer 3,500 Kelvin because it is, a little bit warmer and a little bit more pleasant to be in. I find 4,000 or 4,100 Kelvin to be a little bit too blue and harsh on my eyes, but it is very much personal preference. So whether it's better or worse, not for me to say. You got to talk with your owner, and if it's an existing company, figure out what they have in other buildings. That way you're not creating a shock to the system when they move into their new building. and that sort of thing.
Right. So the answer is it depends. Got it.
Correct. Short answer, but I gave you a long-winded one.
Thank you. All right. So the next question, Michael, I'm going to ask you first because you just touched on this. And then Tyler, you might have a little bit of feedback as well. So Michael, this person is curious about the sometimes requirement on lighting that is controlled by occupancy sensors. So switching lighting off, what's the reason for lighting being on manually?
So let me reread that question again. So what are some of the reasons that the lighting on being initiated manually? So the reasons to initiate the lights on manually would be if an occupant, let's say it was an individual office and there was enough daylight and there isn't actually daylight controls in the room. So if you had a occupancy sensor, which automatically turns the lighting on, versus a vacancy sensor, which somebody physically has to either touch a button or flip a switch to turn the lights on. The manual on would, if, for example, somebody thought there was enough adequate daylighting or side lighting, they don't want the lights on, they could actually not push that button and the lights would not come on. But once that person pushes the button, the lights would come on and then it would stay on with the occupancy sensor. I think that answered the question, Tyler. I don't know if
I'm going to add to that. I'm going to add to that. So there are some codes that require manual on. So that would be one reason why you would absolutely have to have manual on. Specifically, Title 24, a lot of spaces now are required to be manual on. So you have to have that button to click the lights on and off. And it's purely just for energy savings. You know, for instance, if you have a row of private offices and you're walking down the hallway and people didn't close their office door when they left or their huddle rooms or whatever, every time you walk past that room, if it's automatic on, that light's going to come on. So, you know, it's an energy savings point as well to have them as manual on in those spaces.
All right. Yeah. Excellent. Thank you. Next question, Michael, this one's for you. What commissioning tasks are involved in lighting?
So, yeah, that's a great question. I think the biggest mistake in commissioning is not getting the engineer or lighting designer involved in the very beginning of the project. So there is two documents. One's called a owner's project requirements, or OPR, where a owner, if they don't have all this already written down, but they would put down, the lighting designer engineer would help them with the requirements. For example, we want 50-foot candles in this particular room, or we want 30-foot candles in another room. So those would be the owner project requirements. And then the basis of design would be what the engineer or lighting designer would put together as far as how are they going to accomplish the owner's project requirements within the commissioning. And then you've got all your different design phases. So the commissioning authority or agent should be present for all of those. A lot of times they wait until the end of design or when construction starts to get the commissioning agent involved. And then that's where you find out maybe there's an issue with their design. And the commissioning agent, it could be the lighting designer, is to review all the shop drawing submittals, but they actually aren't necessarily the ones that, or I'm sorry, the commissioning agent isn't necessarily the one that makes those changes. If it's a different person than the original specifier, they would point out, hey, this particular luminaire, we noticed something about it. Maybe it's IDLC compliant, for example. So basically commissioning for lighting involves the entire design and construction of the project.
Very good. Thank you. We have time for just one more question. And Tyler, you are the lucky one. What is R9 of 50?
So for those of you that aren't familiar, and I know Michael mentioned this earlier, CRI, which stands for Color Rendering Index, is a set of colors. It was originally 1 through 8, and now there are, I don't remember, I think it's 13 or something like that. I don't have the exact number in front of me, I'm sorry. But so each one of those numbers, so R1, R2, R3, R4, R5, R6, R7, R8, are all specific colors, and there is a control color which is tested against the color produced from a light source. And that control color is what it's supposed to look like under sunlight. So they took the color swatch out into the daylight, looked at it under daylight and said, this is what this color is supposed to be. Then they brought those same color swatches inside and they tested it against that light source and said, oh, it's, rated 1 through 100 for each color. And this is how close on that spectrum it got to being that control color swatch that was outside. So R9 specifically stands for red. So when we say an R9 of 50, we are talking about how close the red is produced by this luminaire to the control sample of that red swatch outside. So that's in general. And I just want to say one last thing, which is not on this question. A lot of you have mentioned that the Ies Handbook is out of date, and you are correct. They do recommend that you look at the lighting library and specific lighting practices. That being said, if you don't have that lighting library or those recommended practice, it is still a good rule of thumb to follow the lighting handbook. It may be out of date, but it is better than nothing. So just putting that out there.
Right.
All right, that's it. Thank you.
Good. Thank you. Well, and I'd like to wrap up by thanking these extraordinary subject matter experts, Michael Chow and Tyler Guylock, for sharing their extensive knowledge of lighting systems. And I'd also like to thank Lutron for supporting this education session. Before you go, we need your feedback to improve future education sessions. A short survey will pop up on your screen as soon as this webcast ends. Please take a few seconds to complete it. Finally, on behalf of Consulting Specifying Engineer and CFE Media and Technology, thank you for joining us, and we'll see you again at the next education session. Goodbye.